Okay, so we will go into the exercise session very soon, but I just had 3 more slides to show on the notebook. So let me finish these 3 slides, and then you are all set for the exercises. The previous notebook that I showed was called One Time because the time was fixed and we wanted to plot the perturbations as a function of wave number k. But sometimes you are interested in the opposite. You want to fix one wave number k, and for this wave number, you want to follow the time evolution of the perturbations from the early universe until now. So you have a script doing it called 1k.py here, with again the different fluctuations relevant for the CMB. The time here, some characteristic time like sound horizon crossing, equality recombination, and you want to follow your perturbations as a function of time. So to do this, there is a last important command that you should know. It's k output values. We have not yet seen k output values. So k output values will be one or a list of values of k at which you want to store the full time evolution of the perturbations. In this example, I only want one value of k. If I wanted many values of k, I would pass here a string with numbers separated by commas. So k is now fixed to 0.5, and you remember by default, if you have forgotten, you can be sure it's 1 over megaparsecs. Okay, so after doing this, we run class. And now, in order to extract this perturbation, we have seen get background, get thermodynamics, get transfer. Now we see a fourth one, which is get perturbations. It will do this job of giving us the evolution of perturbation as a function of time. So first, get perturbation will be an array containing the values for all the k's that were here. But there was only one value of k. So I'm interested in this array for the entry scalar and the first mode. Suppose that I had scalar and tensors. I would get scalar and tensors here, and I would have 0, 1, 2, 3, 4, and they would refer to the different values of k. Here I only have scalars. I only have one value of k. So to get the evolution of perturbation for the scalar and this value of k, I evaluate the output of get perturbation with these indices, and I put the result in 1k. 1k is still a dictionary, so I will look at the keys inside with the view keys or keys, and I see all the different columns. So now one column is, there should be somewhere conformal time. Yeah, conformal time is here. The corresponding scale factor, and then not all, but the most interesting perturbation. We have the perturbation of the photons, which are delta G, delta gamma, theta G, theta gamma, and shear G, which is sigma gamma in the language of Mayen-Bertschinger. So it's the anisotropic stress or shear. There is the same for the ultra-relativistic neutrinos, for the baryons, for the metric fluctuation, psi and phi, etc. So, knowing my keys, I know that if I take my one key for tau, I get a list of tau, and one key for delta gamma, I get a list of delta gamma that I rescale by 1/4 in order to get theta 0. The same with other variables. And for those who arrive late, once I have this, I can make a plot, like in the previous slides, where for a given wave number, I have the evolution of all quantities as a function of time. And then if you have new physics doing something funny, say, at the time of equality, you will see this something funny here. Okay, so the scripts I've shown try to cover the most basic usage of the Python wrapper of class. And as a final plot, let me show you the most elaborate script that we ever wrote, I think. You have it also. It's called manyk.py. And here you reproduce this three-dimensional information. You have k, you have time, and you have the amplitude of a transfer function. Here theta 0, here phi. And it was done like the previous case, but I told you that you can pass several values. So in order to do the last plot, we used k output values, but for many values of k, about 100 values, in order to sample our k. Then get perturbation return a bigger object, where here the index could vary from 0 to about 100. For each mode k, we had then the evolution of the perturbation as a function of time. And then using some nice pyplot commands that you can find in manyk, it was possible to show this kind of two-dimensional or three-dimensional, if you count the color as a dimension, plot. Okay, so now you have all these scripts, and with this, when you want to do a figure, it's your choice to write your own script from scratch or start from one of our examples and modify it to your needs. Very good. So I finally finished this lecture. Now we are back in time with a schedule. And we have 1 hour for easy exercises before Christian starts to talk about the second order code, which is song. So I think that the link to the Dropbox has been circulated. Yeah, very good. Yes. Do you have something called many times instead? Yeah. Then it's a typo on the slide. Somebody already told me, I forgot to correct. It's not many k, it's many times. Yeah. Thank you. Okay, so we have here these exercises. The first one is to be done from the terminal, so it's very progressive. And then you don't have to do all the exercises and in this order. You can select what matches more your needs. If you are more a CMB person or a large-scale structure person, you will be attracted by different exercises. So select the exercise which looks closer to what you do in your research, but they are more or less in order of growing difficulty, knowing that all these exercises of the first day are relatively easy. So in section 2, you have to write some notebooks. First to play with the output CLs, then to plot some output thermodynamical quantities. Then you play with the inflation simulator, in case there are inflation fans here. Then you play with the matter power spectrum to make a plot on the impact of omega B on the matter power spectrum. Later on, you try to reproduce another plot from the book of Scott Dodelson. It's this plot, and you have to play with the evolution of perturbation as a function of time. So it's like what we called 1K. And by the way, I don't think it's secret. There will be an update of Dodelson's book. And okay, we collaborated on doing the figures with class, actually. It's in process. And the most advanced one would be this one. No, there are other ones, in which you try to see the evolution of quantities as a function of time in order to see some very nice physics. So the plot I showed you in 1K was nice to explain CMB physics. This is nicer to explain structure formation, what leads to the P of K. You have time here, you have different fluctuations in log scale, and the green is cold dark matter. So cold dark matter is frozen outside the Hubble radius. Then, as you know, it grows logarithmically during radiation domination and linearly during matter domination. And this plot shows it very well. It shows also that the baryons first oscillate with the photons, and after the baryon drag time, they asymptotically reach the same value as cold dark matter because they fall in the same gravitational potential well. So with this figure, you understand all the physics behind the shape of the matter power spectrum pk. So you can try to do this figure with your own style. And then in 2.7, you try to reproduce another nice plot. It's from a paper of Yu Li Pen from CITA. Yu Li Pen wanted to show something about the relative the difference between the bulk velocities of neutrinos and cold dark matter, which can be very large. So at some point, Thomas Stram was studying this paper and said, it's a very good exercise for the class tutor session. So you can try to do it. And then from 3 on, you have to modify the code, so it's more for tomorrow. So depending on the fact that you are a beginner or an experienced class user, you can start these exercises at different levels. The idea is that I will help you, and when you have some results, you can show them to me. If they look nice, they can be put in the Dropbox. And then you will have the eternal glory of having put the first solution to the exercises. And also, when you want, it can be tomorrow, it can be next week, it can be in 3 weeks. I can put the explicit solution, so the notebooks solving each exercise, inside the Dropbox because I have them somewhere. Okay, so now we will circulate and see if we can help you.